All right, let's get into it. We're about to pull back the curtain on a piece of industrial machinery you've probably never even heard of. But trust me, it has a huge impact on your daily life. The best way to think about it? It's basically the world's most powerful industrial-sized salad spinner.
Yeah, I know. It sounds like the beginning of a really weird joke, right? You've got a snack, you've got clothes, and you've got an essential oil. I mean, on the surface, you think they have absolutely nothing to do with each other. But they all share this one critical, hidden step that makes them possible.
And there it is, a simple, powerful spin. That's the secret ingredient connecting them all. And the machine that does this spinning, well, it's one of the true unsung heroes of modern manufacturing.
So how does this giant salad spinner actually do its thing? The idea behind it is actually pretty simple, but the engineering is where it gets really brilliant. The official name is a hydro-extractor or a centrifuge. You basically load it up with, well, wet stuff. Could be freshly washed t-shirts right out of the dye or potato chips fresh out of the fryer. You spin it at unbelievably high speeds, and that force literally flings the liquid, whether it's water or extra cooking oil, out and away from the solids.
Now this is where it gets really interesting, because it's not just about spinning as fast as you can. It's about being really, really smart with the physics of it all.
See, the machine creates what's called centrifugal force, and you've definitely felt this yourself. It's that feeling of being pushed to the side when a car takes a corner really fast. Well, in a hydro-extractor, that force acts like an artificial gravity that's hundreds of times stronger than Earth's, pulling water straight out of fabric or oil right off a chip.
And this isn't just a guess. Engineers have it down to a science. They can calculate the exact G-force with this formula. And what's so cool about it is that it's not just the speed, the RPMs, that matters. The diameter of the drum is a huge factor. This means you can get way more power not just by spinning faster, but also by making the drum bigger. A larger machine spinning at the same speed is actually much more powerful.
So, after tons and tons of testing, engineers found a kind of magic number. And that number is 200 G. This became the key performance target.
And this is the absolutely brilliant part. They figured out that trying to spin things much harder than 200 times the force of gravity just wasn't worth it. You start burning a massive amount of extra electricity just to get a teeny tiny bit more water out. So 200 G, that's the engineering sweet spot. The perfect balance between getting the job done and being energy efficient.
Okay, so you know you need to hit that 200 G sweet spot. But how do you even build a machine that can handle those insane forces without just tearing itself to pieces? This leads to a huge choice in the design.
You basically have two paths you can go down. The first is called a hard mount, where you bolt the machine directly to the ground. The machine itself is cheaper, and it's a big but, you need a massive, specially engineered concrete foundation to hold it. The other option is a soft mount machine. This one has its own internal suspension system, kind of like your car. It costs more up front, but you can put it on a standard factory floor, and it's way better at handling a load that isn't perfectly balanced. So really, the question comes down to this. Are you going to build the stability into the floor itself, or are you going to build it into the machine? For older buildings, or any place where you can't just pour a giant slab of concrete, the choice becomes pretty obvious.
Now, when you have a machine that's generating these kinds of forces day in and day out, it obviously has to be built incredibly tough. But you know what? More importantly, it has to be incredibly safe.
And that all starts with using the right materials. For most jobs, like in a big commercial laundry, stainless steel 304 is perfect for handling water. But if you're in, say, a textile dye house working with some pretty harsh chemicals, you've got to upgrade to SS316. It's got an extra element in it called molybdenum that makes it way more resistant to corrosion from acids and other nasty stuff.
But the real challenge is dealing with all the dangers. First up, you've got the obvious one, electricity. We're talking extremely high voltage, powering a machine that's often in a very wet environment. Not a great combo.
Then you have the raw mechanical force. I want you to imagine a washing machine on its spin cycle when the load is unbalanced. Now multiply that by 1,000. If the load inside this thing isn't perfectly spread out, it can start to vibrate so violently it can literally destroy itself and everything around it.
And finally, there's the spinning basket itself. The amount of kinetic energy stored in that chunk of metal rotating at high speed is just immense. Any contact with it while it's moving wouldn't just be an injury, it would be absolutely catastrophic.
So how on earth do you protect people from all of that? Well, with a beautifully simple yet totally foolproof safety feature, the lid interlock. It's simple. The machine physically cannot start if the lid is open. And the lid cannot be opened until a sensor confirms the basket is spun down to a complete and total stop. It is just an elegant solution to a really serious problem.
All right, so let's zoom out for a second and look at the big picture. Because this machine, it's more than just a clever piece of engineering. It's a really critical tool for industrial efficiency and, honestly, for sustainability.
So why does all this matter so much? Well, for one, getting all that extra water out before things go into a dryer saves an absolute fortune in heating costs, whether you're using gas or electricity. It also makes products better. Think crispier chips, more evenly dyed fabrics. It allows factories to capture and reuse their water. And the bottom line for any business, these machines pay for themselves over and over again.
And this quote from an engineering report just nails it. It says it all, really. The better the machine is at spinning things dry, the more money it saves. It's that simple, that direct.
So the next time you pull on a t-shirt or grab a potato chip, maybe you'll think about that incredible, invisible spin that helped make it. And it kind of leaves you with a question, doesn't it? What other hidden machines are out there, quietly working behind the scenes, making our entire modern world run?